What's up, gangsters? It's time for a video that I have literally thought about doing for years and just never gotten around to. If you keep up with much of my nonsense, you may recall that a few months ago I had an article published in Scale Aircraft Modeling about paint chemistry. And at the time I mentioned that I would make it into a video as soon as that month's copy had gone off sale. So now's the time, and so that's what this video is going to be about. Now, why am I doing a video, or why did I do an article about paint chemistry? Because I know a lot of you guys are like, yeah, whatever. We already know about everything about paint chemistry. Well, first of all, anybody who claims to know everything about paint chemistry is going to be met with a lot of skepticism, from me at least, because the simple fact is none of us work for the paint companies as far as I know. And even if somebody did work for one of them, there's really no way to know exactly what the other paint companies are doing because we just don't have access to those recipes. The good news is that paint technology is literally thousands of years old in some cases, and a lot of that technology has been pretty well documented. So, between what we can learn from good old-fashioned research, our own experiences, what our noses tell us, what the reactions that we see tell us, there's a lot of things that we can say with at least confidence that we're making an educated guess when it comes to paint chemistry. But I want to make it very clear before I get into this article or this video that I'm not saying that anything I say is guaranteed to be true. I believe that what I'm saying is true, but again, I don't claim to be in possession of any recipes, and I'm left, just like everybody else, to do my research and come to what I feel are the most educated conclusions. But anyway, back to why. Why do we need an article about paint chemistry? Well, look, there's a lot of confusion out there. I don't think a week goes by that there's not a thread in one of the Facebook model making groups about paint chemistry. A lot of guys, especially new guys, get confused because we have these different types of paint that we work with, and it's not always clear how they're supposed to work or work together or whatever. And the paint companies themselves don't really do a whole lot to help clear up any of the confusion. Labeling on paint jars is one of the most frustrating things for me because it is just so often so bad and so uninformative, and actually creates a lot of confusion. I mean, take enamel, for example. Enamel is a word that means a bunch of different things. It's the stuff that's on your teeth, hopefully. It's a word used to indicate the baked on ceramic coating on some types of metal signs, different things like that. It's kind of an old-fashioned thing, but that had nothing to do with paint. And then, of course, there's paint itself, and then within that context, some people have different ideas of what exactly an enamel is or what that term means. So, look, it can just get pretty confusing, and I just have felt like that, given what I've tried to do with my channel, that a video about paint chemistry just made good sense. Okay, so let's get right into this. As you can see, I've got a collection of paints here, and I feel like I've got something from pretty much every category. Well, except oils. I forgot to get those out. We'll talk about those too. I didn't include those in the original article, but I feel like it's important to talk about them because for a lot of us, oils are a very important paint category when it comes to weathering and figure painting. So we'll put them in here as well. We'll put them right there next to the enamels, and that'll make sense here in just a little bit. But the first thing that I'm going to talk about is acrylics. because I think it's probably the most commonly used type of paint at this point in model making history. That hasn't always been the case. I know when I first started doing models way back in the day when I was a kid, like in the 80s, acrylics weren't really even a thing. It was all about enamels and maybe a little bit of lacquers. But I remember the very first time that somebody suggested that I use a water-based acrylic paint. I had no idea what I was doing, and it was a total failure. And the acrylics just weren't any good back then. But they are a lot better now and are very popular because they are relatively non-toxic and they come in lots and lots of colors. Now, their popularity is also one of the things that kind of makes them problematic, because acrylics, even though they are, we think of them as a specific category of paint, the truth is that there's lots of different recipes. I mean, acrylic is kind of like sausage. We can all agree that it tastes good, but there's lots of different ways to make it. And so it can get a little bit confusing. I think that it's important right here at the beginning to define what we mean by acrylic, because it is honestly a bit of a bastardized term. What you have to understand about the term acrylic is that it is short for polymethyl methacrylate, which is a family of polymers that gets used for all kinds of things, from fake fingernails to bulletproof windshields in the form of plexiglass, Lexan, and lots of different things in between. It's a really versatile polymer material, and depending on how you formulate it, you can use it for multiple different things that seem to be completely unrelated, and you'll see an example of that as we go through all of these. But the bottom line is that even though we call this category of paints over here acrylics, there's, I personally am skeptical about exactly how much of it is acrylic in the strictest sense of the word, because you've got things that are also called polyurethane acrylics. When you take a look at the Badger, for example, Badger Surface Primer is a waterborne polyurethane acrylic. Aquagloss is a clear acrylic varnish. Even Future is a clear acrylic varnish. Tamiya X22 is a clear acrylic varnish. So those three things all sort of do the same thing, but they definitely are not the same. And anybody who's used all three of them knows that. So acrylic is, another way to think about it is that it's kind of like cake. Cake is an entire family of desserts, and depending on what type of flavoring you put in it, depending on what type of, how you make it, how you bake it, you can get very different results, but it's all still dessert. So hopefully that analogy makes sense. Now, so we've got some examples of what I would kind of call a normal acrylic. Some people call them latex acrylics, some people call them vinyl acrylics, some people call them water-based, whatever. There's lots of different names for them. But the truth is that when it comes to paints like this Vallejo Metal Color acrylic, this Mission Models acrylic, this Vallejo Model Color acrylic, this MIG acrylic crystal, and this also applies to paints like AK, Hataka has a line of acrylics, even MRP has a line of acrylics now. There's a bunch of them out there. The only real single unifying term that I think makes sense based on what I've known is that all of these could be called emulsion acrylics. Now, what does that mean? And how can it work if it's a water-based or a waterborne material that's essentially got a plastic polymer resin? Okay, so emulsion is a process that basically allows you to have a material in suspension in a carrier, which in this case is water. And a good analogy for thinking about the way that an emulsion acrylic works is to think about what happens if you have a greasy pan in your sink and you fill it full of water and dish soap. The dish soap is an emulsifier. It causes the grease in the pan to break up into grease particles that are then suspended within the water that's in that pan. And as long as the pan stays, the water stays there and it stays mixed up, that's what you've got, is kind of this soup of grease and soap and water. But if you allow the water to evaporate, what you have left on the bottom of the pan is this film of grease that is a lot like what it was before you actually started trying to wash the pan out. And that's really a lot the way that an acrylic paint like this works. It works through a combination of both drying and cross-linking. All right, and so now it's time to define some more terms. Drying is drying. That's basically when the liquid carrier evaporates and you're left with whatever. Mud dries. When the water goes away, you have dirt. But the difference between that and an acrylic paint is that mud can be reactivated and an acrylic paint can't. And that's because of the second part of the process, which is curing. Okay, now curing is a process that you'll be familiar with if you've ever used epoxy, two-part epoxy. You mix the A and the B, it gets a little bit warm, you go away for 5 minutes and come back and it's hardened up. What's happening there is cross-linking. And cross-linking is a very common chemical process that basically means that two separate types of molecule chains get together and spontaneously join up to form a third material. And it's really common with resins of all sorts, like the kind of resins that are used to cast aftermarket parts that we use for our models. Those are thermosets, meaning that they undergo that cross-linking process to harden. So what happens is with acrylic paints or emulsion acrylics is that as long as they're suspended in water, everything is fine. But once the water goes away, once it dries and the resin is exposed to oxygen, the oxygen acts as a catalyst, and that causes the cross-linking process to kick off, and they form that skin that we're all so familiar with. And that's why they can't be reactivated by their carrier. So if you've got, a cured acrylic skin on your model, you're not going to wash it off with water. Now, I know people will say, well, but I use IPA, isopropyl alcohol, to strip acrylic paint off of my model. Obviously, that's a fair comment, but there's a difference between destroying the paint and reactivating the paint. And when you use IPA to strip an acrylic paint off of something, what you're doing is you're basically just breaking it down to the point where it falls off. You're not going to then and put a brush in that soup of paint that you've taken off your model and IPA and use it again. You could never do that because the paint is no longer in its original form and it never will be. So that's what basically defines an acrylic paint. It doesn't necessarily mean that it's water-based, and we're going to get into why that's important here in just a second. Now, some of you guys might be saying, wait a minute, you can't finish talking about acrylics without talking about Tamiya. And that's true. It's also true of Mr. Hobby and the new AK Real Color. Now, some people might say, whoa, wait a minute, those aren't true acrylics. So let me address that. The first thing that you have to know is that the term true acrylic is really just nonsense. And it's a misnomer that seems to have come from the idea that acrylic means it has to be water soluble, and that's just simply not true. Because these, as far as anybody knows, are alcohol-based acrylics. And you can kind of see that with the little flammable warning on the side there. And that's true even though, like with Mr. Hobby, they try to fool you and tell you that it's aqueous. Now, why they do that is anybody's guess, but I suspect that some of it has to do with being able to ship the stuff without getting into the hazardous material categories. Anyway, the point being is that these are also emulsion acrylics. It's just that they work at their best in that respect. when they are used with a blended alcohol thinner like Tamiya X20A. Some people think X20A is just nothing more than IPA and something else. That's really not true. X20A is actually about 54% water, and the rest is a blend of alcohols, which may or may not be isopropyl alcohol. Same thing with thinners like Ultimate Modeling products. This is a blended alcohol thinner, and I think it's probably safe to say that this Mission Models thinner is also. Mission Models want you to use nothing but their thinner with their paint, but the fact is you can use other alcohol blended thinners with it as well. But that's not to say that all of these over here are also universally thinnable with alcohol. Problem with alcohol is that it is also a family of materials. There's a bunch of different kinds of alcohol. Methanol, ethanol, butyl alcohol, isopropyl alcohol, there's a ton of them. And as anybody who's ever tried to thin model color with IPA knows, they don't all necessarily work. So you can't say that all of these are equally thinnable with alcohol. They are, however, all pretty much thinnable with water. These over here don't do as well. They don't form as strong of a paint if you thin them with water. But yeah, you can totally do it. All right. Now, and before I move on, anybody who's familiar with these three paints know that there's more to say about them, but we'll get to that here in a minute. First, let's talk for a second about enamels, okay? Enamels are pretty simple. They were kind of, like I said, the original paint that a lot of us started out with way back in the day. But really where we see most enamels these days is in the form of weathering products. But we have some that are out there that are pretty common and pretty good, okay? This AK Extreme Metal says right here on the side of it that it is an enamel paint. Same thing with this Model Master Chrome. All right, now what makes it an enamel, as far as we know, is that it works off of a resin that is called an alkyd-based resin. And I'm not going to try to even explain the chemistry of that, partly because I don't completely know it. It's kind of confusing, but the bottom line is that it's a resin that requires a curing process, just like a lot of other resins. But the difference is that it is that the carrier is mineral spirits. And that's really kind of to me, that's the simplest way to know that you've got an enamel. If it smells like mineral spirits, it's kind of got that diesel smell. If you can thin it with mineral spirits, then you pretty much know that you've got what we call an enamel on your hands. Hopefully not literally on your hands, but you know what I'm saying. At any rate, once that mineral spirits carrier evaporates, then you get a similar curing process as you do with any other kind of paint. It's just that one of the disadvantages with enamels is that curing process can take a really long time, sometimes even weeks or months. And you know, if you've put a warm fingerprint in the surface of what was otherwise a pristine model that was painted with enamels, you know exactly what I'm talking about. Now, why do I have oil paints sitting right here with enamels? Okay, the reason is because a lot of people think that enamels and oils are basically the same thing, and they are not entirely wrong. Okay, the reason that they're pretty similar is because they both operate on kind of the same mechanism using a resin that can be reduced with mineral spirits. But enamels pretty much, as I said, use the alkyd-based resin, and that's really a synthetic material. And you'll notice that this tube of Winsor & Newton oil also says alkyd on it. Okay, because again, this is basically a synthetic version of the actual oil that's in a traditional oil paint like this one right here. And what that oil is it's a material that's called a drying oil. And those are things like walnut oil, linseed oil, safflower oil. They basically, I mean, it's again with the confusing names, it's a resin that requires oxygen as a catalyst to cure. And as anybody who's worked with oils knows, that can take a long time. But that's why I've got these sitting right here with the enamels, because they do definitely have something in common. There's no doubt about that. Okay, so to close out the discussion on enamels, the main thing to remember there is mineral spirits is the thinner that you are almost always going to want to use with these. You can use lacquer thinner with enamels. That's certainly doable, and there are people who like to do that. But you should never use mineral spirits with lacquers. And you definitely should never use any alcohol-based thinner or water-based reducer of any kind with these paints, because it's just simply not going to work. All right. So now that we've mentioned lacquer thinner, it's probably a good time to go ahead and move on to discussing lacquers. Okay, and that is my personal favorite type of paint. And anybody who's ever used products from MRP, like this wonderful stuff, Guns, Mr. Color, anything in the Mr. Color, Mr. Hobby lineup that's got a C in the code is a Mr. Color paint. It gets a little confusing with Mr. Color because some of them, very clearly say Mr. Color in very loud letters. Some of them say Mr. Color in very small letters, and then right there next to it they've got the Mr. Hobby. But the way I like to think of it is Mr. Color is their lacquer stuff, and Mr. Hobby is their emulsion acrylic stuff. So anyway, the new Tamiya LP paint, the Lacquer Painto, as it's kind of fun to call it, is a lacquer. All clad, most of the all clad metallics are a lacquer. They have 4 high shine finishes: the chrome, the stainless steel, the polished aluminum, and the airframe aluminum that are some kind of other lacquer that's more alcohol based. I don't know. It's definitely not the same. It's a lot more fragile than a regular lacquer finish. Anyway, these are all lacquer paints. Now, lacquers have been around for a long time, about 100 years. They were originally invented in the 1920s, and they were originally known as cellulose paints because the resin for these paints was made from cellulose, which was also known as gun cotton. It's basically the same thing. It's in the same family as nitrocellulose. But you don't have to worry. If you drop a bottle of lacquer paint, it's not going to explode. But part of the reason for that is because since the 1950s, almost all modern lacquers have an acrylic resin base. Wait a minute. What? Well, yeah, okay, that's why it says acrylic lacquer on that label right there, all right? Remember how I said that acrylic is a family of polymers that's really versatile, that can do a lot of things, and that you can make 2 things out of the same raw material that really don't seem to be that closely related? Well, here you go. I said there'd be an example of that, and that's exactly what you've got. These things, this Model Color and this MRP, both have versions of an acrylic resin in them, but because of the way it's blended, it does 2 totally different things. So, the only thing that you really have to know about that difference is that what happens with an acrylic lacquer, I really hate that term. I wish it would just go away because it creates so much confusion. A regular lacquer operates purely through a drying mechanism. Okay, so what happens is that you've got a carrier, lacquer thinner, and it basically melts the resin. It basically dissolves it. And when the carrier evaporates, the resin base basically returns to a hard, durable sort of plastic shell. Now, if that's the case, how is it that we can use something like this on polystyrene? If we know that it will sort of melt plastic, the reality is that it doesn't really happen that much when you're spraying this on there because you're not really using enough. But you do get a certain amount of bite into the surface of your plastic model, and that's one of the advantages of lacquer paint, is it forms a really good bond. Anybody who's used both lacquers and these emulsion acrylics knows that this forms a kind of a skin that doesn't really bond to anything, and it will in fact just peel right off if you're not careful. This, not so much, because again, there's a sort of molecular bonding between the paint and the surface of the model. Now, if you take straight up lacquer thinner from the hardware store, like this stuff that I use for cleaning my airbrush and I use it as thinner for some things. Yeah, if you dunk your model in a tank of that, it's going to melt. But if you're using a thinner like this wonderful bottle of Unicorn Tears right here, Mr. Color Leveling Thinner, or this Tamiya Lacquer Thinner right here, these are formulated to be less aggressive. So you can thin any of these materials with those with total confidence that you're not going to destroy your model. Basically, lacquer thinners are all kind of similar in composition. They all have similar ingredients. It's just that they use different amounts of each thing in different proportions to create a thinner that is either more or less aggressive, that evaporates faster or slower. Like for example, this thinner here is basically a slow lacquer thinner, which means that it's got less of the fast evaporating compounds in it so that it evaporates more slowly on hot days. That's a thing in auto body shops where they have to operate maybe on really hot days. At any rate, all of these materials right here are straight up lacquer paints. Okay, yeah, I know I talked about the exception with this stuff. But again, these are pretty much straight up lacquer paints. And they work great. Now, this is also the time where we need to revisit these three right here, because anybody who's used these should know that they are also reducible with lacquer thinner. And I know this gets pretty confusing, but this is why I call this a hybrid acrylic. Because if you thin this with alcohol or water, it basically behaves as an emulsion acrylic right alongside these others over here. But if you reduce it with lacquer thinner, it basically dissolves the resin and forces it to act as a lacquer like these over here. And that's one of the reasons why this is such magical paint and why it's so popular, because you can thin it with so many different things and it really works pretty well with any of them. But in my opinion, it absolutely works the best with lacquer thinner. And that's the same thing is true of Mr. Hobby and the AK Real Color. So, again, you just have to remember that with acrylics, it doesn't necessarily mean that it's water-based. If there's one sort of myth that I want to try and really dispel with this video, it's that acrylic does not mean water-based. Okay, now that we've covered all of these, which are the most commonly encountered in our hobby, there is one more that I want to talk about before I forget, and that's urethanes. And this is really something more for the car model guys, because urethanes tend to come as a two-part or a 2K material. And all that the 2K means is that you've got a bottle of resin and then you've got a bottle of hardener or catalyst, because guess what? Urethanes operate on that thing we already talked about, which is the cross-linking mechanism. So whenever you mix this stuff up with the catalyst, you actually have only like an hour or so before it starts to really harden up, which means you definitely never want to leave it in your airbrush. But what you get is, with these materials, is a really hard urethane shell. I mean, this 2K clear urethane is basically the same kind of gloss that you're going to find on your family car. And, you know, as you know, it's super durable. Now, the main thing that you want to know if you're going to use any of these 2K materials, and this is a 2K urethane primer that also requires a hardener. The main thing you need to know about those is that they're not deadly. Some people like to act like they are, but the resins involve a thing called isocyanates. And isocyanates are definitely known to be carcinogenic. You don't want to get them on you or in you or you know, whatever, if you can help it. I mean, obviously, if you get a little bit on your hand, you're not going to grow a third eye. But you do need to be a little bit more careful maybe with these than you would with some of these other materials. You definitely want to use good respiration, good ventilation. And you really should be doing that with all of your paints. But it is certainly more important with the 2K stuff. Now, some people will talk about 1K. I mean, that's not really a thing, and that irritates me even more than the term acrylic lacquer, because at least acrylic lacquer is based in some kind of reality. But 1K, yeah, it's not a thing, doesn't exist. However, there are single-part urethanes. And my understanding is that that's what this paint is. It does not require a hardener because it catalyzes with oxygen, which honestly makes it pretty much the same as any other paint that starts to cure once it comes into the presence of air. So, at any rate, I think that pretty well covers all of the basic types of paint that you're likely to be using as a scale modeler. Okay, so there we go. Way more than anybody ever wanted or needed to know about paint chemistry for model makers. I don't really know what more there is to say. I mean, we've talked about water-based acrylics. We've talked about alcohol-based acrylics. Talked about the fact that acrylic does not mean that it has to be water-based. That these really are emulsion type paints and that they come in lots of different flavors. We've talked about good old enamels and how similar they are to oils, and we've talked about my favorite, lacquers. Talked a little bit about the history of lacquers, why lacquers are awesome, and even threw in a little bit there about urethanes, which is something that honestly most of us are unlikely to ever need unless you are doing a really, really high shine gloss coat. So I don't really know what more there is to say. I have to apologize for the flies. This is the time of year where they all want to come in the house to try and stay warm. Anyway, look, really, the bottom line is that while it's kind of nice to understand, some of this chemistry stuff, it's really not necessary. At the end of the day, all any of us really need to know is how these paints interact, right? It's good to know, for example, that an acrylic can take just about anything over the top of it. We know it can definitely take an enamel wash. We know that you can spray a lacquer clear coat on top of an acrylic base coat, no matter how much some people may tell you never to do that. We know that it's probably not a good idea to put an acrylic on top of an enamel unless you know that that enamel has been left to cure for 375 years. You just never know when those things are fully cured. And the last thing you want is your enamel to keep outgassing and bubble up underneath your lovely acrylic top coat. So, really it's those basic interactions that are really important to know so that you can take advantage of the differences in materials to do things like put an enamel wash on top of an acrylic color coat. But beyond that, I get that most of that stuff is really not necessary. But what can I say? I'm just kind of a paint nerd, and I like knowing all that stuff. And, sometimes it might help you win a bar bet. Who knows? At any rate, I hope that you guys, don't think that that was all just a complete waste of time, and that some of that information was at least interesting, if nothing else. And as always, I definitely appreciate you watching. Much love.